In this video, we're going to talk about immediately invoked functions. So we've already looked at functions, and this is ideally what we covered in functions. We saw the life cycle of a function, the basically structure of a function, and this is all good. We also even actually went ahead and looked at arrow functions as well, which are kind of an easier way of, let's say, kind of a shortcut of the main functions, but it has their own use case. Now we're going to look at immediately invoked functions. So immediately invoked functions, we refer to them as immediately invoked function expressions. And these are ideally functions that run as soon as they are defined. So the moment you define a function, it also runs immediately. It is a JavaScript pattern that has existed before, and it's a pattern that we usually use when you want to create a new scope. How it helps usually is when you're working with variables, sometimes you want to encapsulate those variables. Encapsulation it refers to the process of information hiding. So you want to hide certain information. This actually is similar to what closures do. They're two totally different concepts, but they both hide information in a specific scope, and then you only expose a specific aspect of that information. Now, to understand this, to understand these immediately invoked functions, you're going to encounter them when you start looking at ES modules later on. But let's just first of all look at a simple structure of what it looks like. So you first of all you write the function inside of a set of parentheses. Okay, then you just write function. So you write function, you don't give the function even a name. You'll have your calibrate or other parentheses where the parameters go if you have any. Then you're going to have curly braces. In here, I just want this to print a simple statement that says console.log, something like, let's say I ran immediately. This is an immediately invoked function, but rather as we've written it, it's still not an immediately invoked function. Like you said, these are functions that execute immediately or as soon as they are defined. And how they're able to do that is because you can call them right outside. That is usually what you do, just like that. You write the function inside of a set of parentheses. Then once you've finished writing the function and you've closed the parentheses, you call it by using that set of parentheses outside here again. So these outer brackets that we've just added, they're the ones that turn the function from a simple function declaration into a function expression. Okay, so what you have before here, this is a function declaration. We've just declared a function. Then now that we've called it, now we've turned it into a function expression. This set of parentheses, they invoke right away. I believe this is clear. Now, you can still use this same concept because as you can see here, this function does not have a name, right? So you can use this same idea when you're dealing with arrow functions. So you can have an immediately invoked function as an arrow function. But let's run this first to see what you're talking about here. So I'll just use node. I call it IIFE, and you see it executes and it says I ran immediately, which is the beauty of it. Then you can use an arrow function as well. So you can just have something like this, and you can have a statement here that says, let's say console.log something that, let's say just I run, something like that. Then you'll just call it as well. So you have your set of parentheses out there, and then you can run your function, and you see it says I ran, and that is it. So this is what we refer to as immediately invoked functions. They're executed rather immediately. They're usually very useful when you deal with stack traces. Now, I'm going to give you this as a challenge. Just go online and Google what is a stack trace, and I'd like you to let me know in the comments below what is a stack trace. And then after that, if again you'd like me to create a video on stack traces, I'll do that separately later on. But this is the idea of an immediately invoked function. But why do we need it? Apart from just the whole idea of stack traces, we've talked about scoping before. When you talked about event closures, we talked about the idea of scoping. Scoping, again, just as to reiterate on that, scoping is the environment within which, or the block within which, a specific variable exists. So there are variables that exist globally, then there are others that are scoped to a specific block of code or block scope that you define. So with immediately invoked functions, as you can see, they are very isolating, right? They are very isolating, which means that you can isolate a scope in here. So if there are any global variables and you don't want those variables that are inside of this to be visible outside of the function, an immediately invoked function is a good way for you to go about that. So you can easily isolate variables here without worrying that they're going to be corrupted or polluted later on by any sort of global functionality that exists in your program. The other thing is the state of your application, right? When you get into React, we're going to talk about state generally, but just it's the word, just as the word itself says, it is the state of something, right? Before you change, or rather, once you change something, it gains a new state, something like that. So when you want to have a private state where you basically hide the implementation details of your program, and then you only expose what you return from that program, then that is a private state. And this is usually how modules work. There's a number of modules that you're going to work with and import in future programs. You'll import like a module. Think of it as a library or a program that someone wrote, so that it makes it easier for you to carry out other things. An example of that, I'd say, think of console or console.log as an example of a module. This is a method that exists, this code that has been written so that this console.log function that we use here can be able to give us what you want, which is executing a specific statement that we tell it to. So this has, rather, the implementation details of console.log have been hidden from us. Of course, you can be able to see the code base that wrote that, but you basically don't see the code base when you're just saying console.log. Think of it as well as when you go to an ATM, you want to withdraw some money. The only thing that you get is the money. You don't get to see how it counts the money or anything that is happening in the background, because certain things are in a private state. The other thing is when you want to basically have a one time setup of something, you just don't want to go through the struggle of adding extra steps to a specific program. You just make it immediately invoked, or it to invoke immediately. And there are many other ways that you can still use this immediately invoked functions. But this, we're going to just talk about this, what you've talked about right now. Later, when you start looking at things such as asynchronous JavaScript, we'll also discuss a way that these immediately invoked functions are used. But let's go ahead and discuss this immediately invoked functions further. So to understand them further, we need to think of it as the anatomy of a function. For you to understand the anatomy of a function, you need to understand a function expression, and you also need to understand a function declaration. We've discussed these terms before, but it doesn't harm anyone to just go over them again. Function declaration are ones that are not immediately runnable by themselves. Okay. Now, what you mean by this is you can have a function. You have a function here, and let's say this function is called f. Let's say foo, something like that. And then it has, of course, a set of parentheses for parameters, and then you have your curly braces. What you see here is a function declaration. Of course, it can have everything else inside, but I'll just keep it one line so that it's easier for commenting. What you see here, this is a function declaration. Okay. Then for a function expression is one that is runnable with a set of parentheses. So if we have another function, let's say, of course, a major, like another example that I can use is an example of an immediately invoked function, right? It has this, you have your set of curly braces, and then it basically gets called out like this. This is a function expression. So I'll have as a comment here, This is a function expression. Another example of a function expression that you can think of is functions that are known as, they're these functions that usually call, for example, like unary operators. But I'm not going to get too much into those. You can go ahead and just check them online. But this is just a similar idea of what happened here. So the first style that you've seen here, which is the style of this function declaration, we use this when you want clarity. So it's mainly clarity for all these kinds of functions that we write. Okay. When you create such a function, the function will also need, just as the normal anatomy of a function as well, a function is going to need parameters. So the question that you ask yourself, of course, is how do you add parameters to such a function? I'm going to just use the origin of the one of these functions that we have here. So I'll actually just use this first one instead of writing any new code. Once you have a function like this, let's say it's a function that does the sum of two numbers. So that means it's going to take in two parameters, let's say A and B. Okay. And then what it's going to do afterwards, what it's going to do afterwards is carry out the sum. So I can use just the const keyword, and we can have, just say addition. Then we'll have A plus B. Again, same thing that we've seen before. And then when you come here, we basically print the result. I'll say the result is addition. What you have here is, you can also use the return keyword, by the way. You don't have to use the console.log. But once you've created this, then you ask yourself, how do you pass in arguments? Because you have to pass in arguments when your function has some parameters. It's very simple as well. You basically pass in your arguments in here. So if you want the sum of, let's say, 23 and 89, just pass them in there. But now, once you have this, let's see, once you run this function, or rather this program, what happens. When you run it, you see you get the result as 112, right? But what happens in a case whereby you don't have a console.log, but you have a return keyword? So you have a return keyword like this. So what do you do when you have a return keyword? I'll just actually just return addition directly, instead of having a long statement there. You can also use template literals for this, but I'll leave it as this. But what happens when you have it like this? You can just pause for a moment and try to figure out. You see, when I run this program, it does not run. I can disable this because you don't need it right now. Let me clear and run it again. As you can see, we don't get any result. So how do you go about such a case where you're using the return keyword? Because remember, we use the console.log just to check the results of a program. It is a way of, let's say, trying to figure out whether there's a bug in your program, just trying to see the results. But in production, we don't use console.log. It's just something that we use in our local machines, in our local environment, when you're trying to test what our program returns as a result or as a value. But what you do in this case is you have to assign the value that it returns into a variable. So I can go ahead and declare a variable here, and I'll call it maybe answer. Then I'll assign it like this because it returns. Remember, the return keyword means that it holds that value. Then that value is stored to answer, the answer variable here there. Now, if I do console.log answer and we run this program, you see now we get the result 112. This is the beauty of arrow functions. You can just use them however you'd like to use them. When you're using these immediately invoked functions, there are a number of patterns that you'd ideally follow whenever you're creating them. So how you can think of some of those patterns is, you can have a function instead of another function. So instead of this arrow, not arrow, but instead of this immediately invoked function, you can have other functions that are inside of it that are doing anything else that you want. So how you can think about it, I've mentioned the idea of a module. Okay. So with the idea of a module, let me use that one. For now, I'm going to just comment out that console so that we don't get any result in here. And just to create a simple, just you look at how a module pattern looks like. So I'm going to create a simple, let's say, counter. Yeah, we're going to just create a counter module here. and we're going to give it an immediately invoked function. So it's going to be a function, and this function does a number of things. Remember, the function is immediately invoked, so you can actually just do that, then try to figure out the internal logic of such a function. Let's say we have a variable in here. I'm going to declare a variable and call it value. Just the initial count. The initial count is 0. We're trying to build a simple a counter application here. Then I'm going to create a number of functions inside of it. Okay. So these functions are going to do or return a number of things. So some of those things is going to return. Let's say you want to increment the value, because again, that is what a counter would do. A counter application, you can increment the value, decrement the value, and you can also use it to fetch the value if you wanted to. So I can create a function called inc, and inc for increment. I just want to write the full name. Then this function can return the full value that you want. So you have a set of curly braces there, and then I'll just say value plus plus. Now, this is something else that you learn about functions. So a function like this one, when you just have it value plus plus, it's going to do the incrementing that you need yourself. So this is one of those cases I was talking about where you don't really need a console.log. A console.log is just there to show you the results of the application. Okay. I'm going to just copy paste this. Instead of inc for increasing, the other is going for decrementing a value. So for decrementing is of course value hyphen hyphen like that. And then I'm going to just copy paste this one again. But now this is what you're going to use to return the value. Okay, so rather fetch the value. So we create a function called get, and all this function is going to do is it's going to return that value. So in this closure, not really closure, but module pattern that we are following, you'll notice that there's a number of things that happen. We have an increment function, and this increases the value of this variable that we have here. And there's a decrement. That is all they do. They don't return anything. They don't print anything. The only function they have is to increase or decrease this value. Then when you want to get that value, we create this other function called get. It's the only one that returns a value. Now, this is what modules look like. For example, when you say console.log, think of the module pattern that is built in as something similar to this. So now what I'll do here is I'm going to return these three functions. Okay. Because there are three functions, how I can return them is I'll use a set of curly braces. Then I'll just pass in that I'm returning the inc function, the dec for decrement function, and the get function. This that I'm returning here, think of this as a public. Think of this as a public API. What you mean by this is someone who is going to use your function already knows that counter exists, or there's a counter feature or counter module in your application, so that if they want to do any incrementing or decrementing of a value, they know that they're going to use the counter function, but they have to specify what property of the counter application that you have they're going to use. Do they want to use it to increase the value? Do they want to use it to decrease the value? Or do they want to use it so that they can fetch the value? That is all they do without having to go through the trouble or the hassle of understanding or writing these programs themselves. So to help them understand that, we usually expose an endpoint to them. So think of this as a public API endpoint, inc, dec, and get. That is what we are returning. I believe you are following. Let's now go and try to make it make sense. Because counter is an immediately invoked function, that means that this function has already called itself. Okay. Which means we can go ahead and try to fetch values from it. So let's use counter. And then I'd like us to increment the value. So what you do is just say counter dot inc like that. You'll notice this pattern seems very familiar. The reason it seems very familiar again is the example I used earlier. When you're using console.log, it is ideally the same thing that you're doing. You don't have access to the underlying code that basically allows you to use the console.log functionality in JavaScript. Now that I've incremented the value, I can go ahead and say console.log. Again, the pattern I'm using as an example here. Then I'll say counter.get. Remember, this is the get function. Okay. Now, the original value was 0. We've incremented it. So we expect the new value to be 1. That is why I'm using this get, because it's the one that returns the value. Let me run this program. You see, we get 1 as the value. 1 is the value. I believe that makes sense. 1 is the value. Then you can go ahead and increment the value if you want. But let me just try to increment it a few times. So if we run this again, you see now the value is 4 because I've incremented it 4 times. And now I can try to decrement the value if I wanted to. So I can do, actually, let me just use this. Instead of ink, I'll just say dec for decrementing. Then when you run, you see we get the value is 2 because this increment, now we have 1, 2, 3, then you decrement by 1. Then now it is 3 minus 2, 3 minus 1 rather, which is 2. So we have 2 as the new value. So I believe this makes sense. We are able to get all this, the information that we have, we're able to receive, we're able to use these endpoints, which is the same pattern that you'll notice console.log usually uses, because it follows that module pattern. Okay, I believe this has made sense. If it hasn't made sense, let me know in the comments below if you'd like a bit more explanation, or also let me know via Discord. There are many other patterns that you can use. This is what you refer to simply as a classic module pattern. There's also a number of other patterns that people use nowadays. So if you have, let's say, a list of items and then you want to add value to the list, you can create a program that does that. Just follows the same module pattern, but that program is, let's say, takes in a list of items, and then you can add items to the list, remove items to the list. Think about the same way you would use your calculator. You only have exposed endpoints. The exposed endpoints that you have on your calculator are, you are able to use the click on the equal sign for you to get the result, click on some other value for you to get a result. That is an endpoint that has been exposed to you. Okay. It is the same thing even here when I'm running something on my terminal. This is an endpoint that is exposed to me that I'm using to be able to run this. And that is ideally the pattern that is being used here. And this shows you the power of immediately invoked functions really, really nicely. We use this again as a just to give you an idea of where you use them apart from these simple modules. In case you want to create small libraries, use it here. You're going to encounter the idea of widgets. So I mean widgets this here. You've probably seen this in our website somewhere, like in a dashboard of our website application that you use. So you can use immediately invoked functions to create these widgets, or when you want just a private state like you mentioned earlier on, you can also use them there. That is what I'm going to just use as an example. There's also many ways that you can use immediately invoked functions when you are dealing with asynchronous functions or synchronous patterns in JavaScript. You do the same, but there's so many other ways that you can do with it. But I do believe this is clear enough for you to understand what happens with immediately invoked functions. But there's a lot more that you're going to learn about it as you build a lot more projects, because their use cases are just so vast. Okay, happy hacking.